Welcome to Understand the Math. In this problem, we're asked to find the standard matrix of T from R2 to R2 that first rotates points 3 pi over 4 radians counterclockwise and then stretches points horizontally by a factor of 3. Let's start by looking at what our standard matrix is. Our standard matrix A for the transformation T is T of E1 and then T of E2. E1 is 1, 0, and then E2 is 0, 1. So what we're going to do to solve this problem is we're going to start with E1 and E2 and see how they transform. I went ahead and drew a graph that we can start with. The first thing that we're going to do is we're going to write down our vectors E1 and E2. So this is vector E1, and this is vector E2. Let's go back up here and look at our first transformation. Let's call this first transformation T1, and the second transformation let's call T2. So we're going to look at T1 first. It rotates points 3 pi over 4 radians counterclockwise. So what we're going to do is we're going to take E1 and we're going to rotate it 3 pi over 4 counterclockwise. So E1 is going to look like this. And then we're going to do the same thing to E2. Let's actually label this one T of E1. And then our T of E2, we have to go 3 pi over 4 counterclockwise. So that's going to pull this vector down here. And let's label this as T1 of E2. So let's go back here, up here, and add a 1 to that one. Now we can look at our second transformation. So let's go back up and look at what that was. Our second transformation stretches points horizontally by a factor of 3. So we're going to take the horizontal component of T1 and we're going to stretch it by a factor of 3. So let's look at T1 of E1. If we stretch this, that's 1, 2, 3. The horizontal component is going to look like this. So we'll label this T2 of E1. And then we're going to do the same thing here. This is 1, 2, 3. So we're just stretching it horizontally. And this is T2 of E2. Now we can write down what the standard matrix of A is. Before we do that, let's write down what T1 of E1 is. That point, because we're at a 45-degree angle and we're in the second quadrant, is going to be minus root 2 over 2, and then root 2 over 2. And then T1 of E2, because we're in the third quadrant, is going to be minus root 2 over 2, minus root 2 over 2. Now we can compute T2 of E1. What we're going to do is just stretch the horizontal component by a factor of 3. So our x component becomes a minus 3 root 2 over 2. And our y component, the vertical one, stays the same. And then T2 of E2, we're going to stretch also by a factor of 3, so that becomes minus 3 root 2 over 2, and then a minus root 2 over 2. To create our standard matrix, we're going to take our T2 of E1 and put it in our first column. So this gives us a minus 3 root 2 over 2 and a root 2 over 2. And then we're going to take T2 and put it in our second column. And this is a minus 3 root 2 over 2, and then a minus root 2 over 2. And that's our standard matrix for our transformation. I also want to approach this problem algebraically. I always find that some students will like a graphical approach and then some other students will like a more algebraic approach. So here's how to do this algebraically. You take matrix A and it is A2 times A1, where A1 is the standard matrix for our first transformation, and A2 is the standard matrix for our second transformation. So our matrix A is A2. So let's think about this. A2 is the standard matrix that stretches vectors horizontally by a factor of 3. So that matrix is 3, 0, 0, 1. And then our first matrix is our matrix that rotates points counterclockwise. So I'm not going to put in the angle to start. I'm just going to write it as theta. So this matrix is cosine theta, sine theta, minus sine theta, cosine theta. Now what we can do is we can go back and we can plug in 3 pi over 4. So this is cosine 3 pi over 4 minus sine 3 pi over 4, and then sine 3 pi over 4, and then cosine 3 pi over 4. Before we go ahead and let's do the multiplication, we're going to write down what these angles are. So cosine 3 pi over 4 is a minus root 2 over 2. Sine 3 pi over 4 is a positive root 2 over 2. Minus sine 3 pi over 4, we pick up a minus root 2 over 2. And then cosine 3 pi over 4, just like in the upper left, is minus root 2 over 2. Now we can go ahead and we can multiply these matrices. We pick up a minus 3 root 2 over 2 in the upper left. In the upper right, we're going to pick up a minus 3 root 2 over 2. And then in the lower left, we have a root 2 over 2. And in the lower right, we have a minus root 2 over 2. And you can notice that these two answers are the same. Either approach is totally fine for solving this problem.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.